Hi, in this lesson I want us to explore the idea of the length of a day and to think about how long a day actually is and whether that's changed over geological time. Now for this lesson you're going to need a ruler, a calculator and some coloured pencils if you've got them. We're working on pages 10 and 11 of your Theme 0 Part 2 booklet. Okay, let's go. The first question we need to ask ourselves is what we actually mean by a day. Now I often ask this question in class and get the answer straight back at me, it's 24 hours. Well, that's sort of true at the moment. But really, geologically, what we're talking about in the length of a day is the time it takes for the Earth to spin around on its axis once. You can actually see that in places like Antarctica here in the summer. These are pictures taken every hour in the summer at this base in the far south, and you can see the sun here doesn't ever go down. And we can track a complete 24 hours as the Earth spins around on its axis. A year is a different thing. A year is the amount of time it takes for the Earth to orbit around the Sun once. Now, we can see through geological time that this hasn't changed perhaps very significantly over the past few 100 million years. But there is evidence that the Earth's rotation on its axis has slowed. The evidence comes from a peculiar type of rock called a tidolite. Now we don't need to worry too much really about tidolites, but there are these sedimentary rocks that are deposited on a cycle that goes with the spring and neap tides. From that we can work out the length of a year from this, and particularly the number of days within that year. Let's have a look at some data. This is the table you've got in your booklet. We can see that we've got different ages through geological time. We've been able to work out from the tidolites how many days there are per year. Now we're fairly confident that the length of the year in terms of hours that we measure now hasn't changed. So we can work out how many hours there are in a year, how many hours it takes for the Earth to orbit round the Sun. Multiply 24 by 365, we get 8,760 hours. That's the length of a year. Now, if the Earth is spinning on its axis, more rapidly, we'll be able to fit more days into that year. That number of hours will be divided up differently. So what I'd like you to do now is I'd like you to complete this table by working out how many hours there are per day at each of these times in the past. And we can work that out by dividing those 8,760 hours by the number of days per year. Have a go at that now and complete the rest of that table. Once you've done that as well, can you work out the mean averages of the ages and also the mean average hours per day? Have a go at that now. Okay, these are the answers I got from doing the calculations. We can see then that the length of a day has gone from 23.7 hours in the Upper Cretaceous right down to 18 hours long back in the Cryogenian part of the Precambrian period. If we work out some mean averages, so we add them all up, divide by the number that there are, and we end up with a mean average age of 390.3 million years and a mean length of the day of 21.7 hours per day. Okay. We're going to plot a graph from this. And this graph is looking for a correlation, how this has changed over time. These sketches give us an indication of whether it's a positive correlation. So there's a strong link between our two variables that goes, and both of those variables increase together. A strong negative correlation gives us one variable increasing, but the other one decreasing. But again, those two things happening in proportion to each other. Bear that in mind when we're trying to interpret the graph that you're going to plot. Okay, you have a piece of graph paper on page 11. What I'd like you to do is to plot a scatter graph using the data you've got from your table, okay, of length of the day in hours against the age in millions of years. When you've plotted all your points, draw a line of best fit. But what I'd like you to do is I'd like to make sure that your line of best fit goes through what we call the double average point. So plot a point, perhaps in a different colour, to show the mean average age plotted against the mean average length of the day. Have a work through questions B and C. There's plenty of hints and tips in the questions. Those of you that fancy having a go to dig deeper, have a go at questions D and E as well. So press pause now and see what you can come up with. Okay, you should now have a graph plotted and your questions answered. Let's see what we've come up with. So we have this graph. Let's plot the points. Okay, the red point marks the double average. You can see there's something of a relationship here, but it's not on a perfect straight line. So perhaps we need to work out what the line of best fit is. Now I reckon it's got to be somewhere through like that, with roughly an equal number of points above the line as below the line. You might have it in a slightly different position, but I'm sure it's relatively similar to that. Okay, if we now look at the rate of change, we can see that days have got longer as we get into more recent time, by about a third if we go back to 900 million years ago. If we think about how quickly that's happened, if it increases by 6 hours in 900 million years, that's 21,600 seconds per day, over 900 million years, which is 9 million centuries. So if we work it out in seconds per century, that means that this is changing by 0.0024 seconds a day in every century. It's another example of how a very small change over large amounts of geological time can lead to big change. So something's clearly slowing the Earth down. And we can see it's something that's having a fairly gradual effect on the Earth. It's not one single event that's doing this. The answer is the moon. The gravitational pull of the moon and the tides that goes with it acts as a drag on the rotation of the Earth, particularly because our moon is so large. We'll look at why that is back at when we get to theme 2. So, to conclude, the length of a day isn't a fixed thing. It's changed over geological time because of the Earth's interaction with its satellite, with that moon. This gives us a springboard into talking about geology that goes beyond our own planet. But that's for another lesson. I'll see you then.